All right, so this is lesson 8 of Python for data analysis. We're going to go to the GitHub page, and this is, sorry, I said lesson 8, I meant lesson 9. Lesson 9, and we're going to go to our lessons folder here and click on lesson 9. So today's lesson is regular expressions, and regular expressions are incredibly handy. These are ways that you can find patterns in text files and search for them, replace them, and this tends to be incredibly useful in data science. I think that it's one of the most important skills to learn, and some of what we'll cover today is not Python. A lot of what we'll cover is not specific for Python. It's more general. We will cover some Python applications, but then we will also cover some other ways you can use regular expressions. Let's go ahead and get this notebook copied, and then we'll run it on our own machines. So we'll go to the raw link here and copy that. And now we're going to go to a terminal, and we're going to go to the SIO209 folder and lessons. We're going to do curl-o, and then in quotes that link. So we downloaded that, and then we're going to do a source activate. And if you have that bash profile set up the way that we did at the beginning of the quarter, you can just type the first few letters and type the up arrow, and that will go through your history and get the last command that you did with source activate. So if not, you can just type it out. So source activate Python 3, and then we're going to do Jupyter Notebook. Okay, so we want lesson 9. Okay, so there's some readings here that you can follow along with on your own time. And so today I will talk an introduction about what regular expressions are. I'll cover the basic syntax, or how you build a regular expression, what the different characters mean, and then I'll talk about some different applications. So I'll use sed, grep, and then we'll do a tutorial with a text editor, either Atom or Sublime Text, whatever you prefer. They both support regular expressions. And then we'll talk about regular expressions in Python, and then there's a regular expression or regex cheat sheet at the end that you can go to when you're trying to remember how to do a certain thing. So again, a regular expression is like a sequence of characters that will help you match or find or replace strings or sets of strings using the special syntax. And a shorthand that you'll see sometimes for regular expressions is regex. In fact, there's certain modules that are called regex, or the one in Python is called RE. And these are really commonly used in Unix. And the way that we build a regular expression, typically we want to match the type of pattern we're looking for, but not any other version. So we can make the regular expression very specific. So if you're feeling lost, you still don't know what we're talking about, I'll give you some examples here. So, for example, if we wanted to match a word that was Bob, Sob, or anything else ending in OB, we can do a dot. So dot will match any character, and then OB will match the OB part. So these would match all of these. If we want to say match whatever character came before any number of times, we can use the star. So this would be a capital L, a lowercase o, and then that can be 0, 1, 2, or infinite number of O's followed by, but in this case it has to be followed by a lowercase l. So LOL would match, but also LL or L with lots of O's and then an L. These would all match this regular expression. Related to that is a question mark. The question mark will say I want to match that character that came before 0 or 1 time, but not any more. So you can see there's already kind of two basic types of syntax that we use in regular expressions. There's the character that we're matching, or a class of characters, which is, say, in this case, it's an O, but it could also be a range of characters or a set of characters. And then there's the how many times do you want to look for it. That's like this dot. Sorry, the dot matches anything. That's like this star or this question mark. And we'll see it. So we want it to match AE, ABE, or ARE. We could do an A dot star E. So this would match capital A, any character, any number of times, followed by an E. This next one here, it has a set in brackets. So this says match capital B, capital F, or capital G, followed by a lowercase a or d. And by the way, all of this is case sensitive unless you hear otherwise. Python gives you the option to make it case sensitive or insensitive, but assume, unless I say otherwise, that everything is case sensitive. So it matters if you use an uppercase or a lowercase letter. So this regular expression would match capital BAD, capital FAD, or capital GAD. This also works with numbers, so we can say match from 0 through 9. And then the brackets are just here used to specify a set or a range. They're not actually going to be in the regular expression. So for example, this would match, and then we're going to say we're going to match 0 through 9 any number of times, followed by a period. So the way that we say we actually want to look for a period is we use this backslash before the character, before that special character, and then it says it's actually going to look for that particular character. It's not going to have this special meaning where it can be any character. Then we're going to match 0 through 9 any number of times. So this would match a floating point number. So say a 3.14159 or 1000.0, etc. So those are just some examples. I'm going to make my head bar here. So the basic character classes are the character itself. So if you want to match an A, you put an A. This is what you're used to with searching for text in a file, right? You just search for the text itself. Or if you want to match any character, you can use a dot, which will match any character except for the new line character, which is the one that comes at the end of the line. If you want to match, I'm gonna move this down. I don't. Logically, I think I'll come to it later. So I can use this arrow here to move this cell down. I can say, okay, I'm going to talk about character classes, and then predefined character classes, and then let's do it. Yeah, that's where I want it. Okay, so again, if you want to just match a character, you type the character. If you want to match any character, it's a dot, except for a new line. And then you have this thing of character classes. So if we wanted to match lowercase b, g, or h, or a period, since the period is in the brackets, it understands that, the computer understands that we want to actually match the period. Then we put them in brackets. If we want to match B, C, D, E, F, G, or H, lowercase, we type B-H. If we want to match all the lowercase letters, A through Z. If we want to match B, C, or a dash, we can type B, C, or dash. But notice that, again, the computer understands that if you type A dash Z, that's A through Z. But if you were to type AZ dash, it would know A or Z or a dash because of the order that you put them in. I think you can also put the dash in the beginning, just not in the middle of those two characters. So there's some conditional logic that you have to get used to. You can also negate a character class. So if you put a little caret sign here before those two characters, you're going to get anything except for a B or an X. So there are some predefined character classes that are now listed here. So if you want to match a digit character, you can type \lowercase d, and that will match 0 through 9. And then there's a negated class of the same, a negated construct of the same class. So this would be a \uppercase d. So this would be anything that's not a digit. So this would be like writing a caret and then 0 through 9. So the next one that you can use is a word character. So this is letters, numbers, and underscores. Those are considered word characters. So if you type a \W, it will match any word character, but not a space. And then the negation of that is a capital W that matches anything that's not one of these characters. And then there's the space character. This matches a space, a return, which is a \R, a tab, which is a \T, a \N, and I have to look up what the \F is actually. I don't know off the top of my head. But these are all space characters, and the \S would be not a space character, so negation of that. So if you want to, people have different styles. I usually write out exactly what I want. So for example, if I know it's a word character, I'll just type A-Z. So another thing here that you need to get used to is this dash kind of joins these two letters, but then the next thing is now a new class or a new part of the class that you're specifying. So you type A-Z, and then you can immediately type capital A dash capital Z, and then 0-9, and then underscore. So this would match anything lowercase a to z, uppercase a to z, 0 through 9, and then a dash. But then if you want to have more than one of those in a row, you can use these multipliers. So we saw the star and the question mark multiplier in those examples. Now we'll cover sort of the full options. So you can put a star after you could do like a /D and then a star that would match any string of 0 through 9s. You know, it could be 5, 7, 2, 3, 4. You know, whatever string of characters you want, it'll match that any number of times, including 0. So if you want it to be 1 or more, you can put a plus there. And if you want it to be 0 or 1, you can put a question mark. But we also have the option to specify exactly the range of matching instances that we want. And to do that, we can use these curly brackets or braces. So instead of putting that star after the character we want to match, we can put these braces and we can say 0, comma, and if we leave it blank, it goes to infinity. So it'd be 0, 1, 2, all the way to infinity. If we want to do 1 or more, we can do 1, comma, and leave that blank. Or if we want 0, 1, we can actually write 0 to 1. If we want exactly 2, we could do 2, 2 or more. 1, comma 3 would be 1, 2, or 3, etc. So there's ways to specify how many times you want that regular expression to match in a row. There's also alternation. You can put a bar, which would be in the class. You can put, say you want to match A or B. You can specify it like this. So actually, I'll put that up here because I think so. It kind of goes with classes, right? So you've either got a set of different things you can match, or you can say I want to match A or B. Well, yeah. No, I'll put it back here. Sorry, I'm indecisive about the order I want to cover this. Okay, so then we have groupings. You can, this allows you to capture a set of characters, and you can do something with them. So, for example, you can replace once you match it in a regular expression, you can then replace it with the part that matched in parentheses later on. So the one that we'll see today, we'll see there's said, but the one that will mainly use is more this Perl style using dollar signs. So this is in Perl, but also in Atom and Sublime Text. Don't worry, I always update the lessons after class, so if I make changes, it'll just be on the GitHub. Finally, there's what we call anchors. So we can anchor the regular expression to the beginning or the end of the string. And what this means is that the regular expression, if we put one of these caret signs, this is not a negate operator in this case. This is a anchoring to the beginning of the string. So it says that that regular expression has to match the beginning of the line or the beginning of the string that we're searching. If there's a dollar sign at the end of the regular expression, it says it has to match the end of the line. So this gives us more power about where we match. So that's the syntax. Now we'll go into some examples.